we go with a little bit of math review. We're going to start off with a problem that you would do if you were doing a density calculation in a density lab. When substances are irregular shapes, we can place them in a graduated cylinder and measure the displacement of water to find the volume. So that is just a standard that hopefully you remember now that you've heard it. But if the water level is down here originally, and then we put a substance in here, the water does not take the same space as the substance, so the water level rises. That rise is called the displacement. And then the amount of the displacement is the volume of the substance. So even though the substance isn't floating up here, we know the difference between these two water levels, the original and the new, is going to be our displacement, and it's measured in milliliters. So that's also another indication. Hey, milliliters is a unit of volume. So that justifies what this statement is. You can use the displacement of water to find the volume. You can also use regular shapes in there. You don't just have to put irregular in there, but you have to be smaller than the graduated cylinder that you are using. All right, so what are we trying to find? I'm underlining what I'm trying to find, the density. Okay, and it measured 10.0 grams on the digital scale. This is a digital scale, so whatever it reads, that's what it is. 10.0 grams is the mass. So even if I did not know the density formula, could I use these units to help me out? Yep, grams is a unit of mass and it's in the numerator. So I'm going to have 10.0 grams in the numerator. And the milliliters is a unit of volume like we just discussed. So that would be on the denominator. So at minimum, I'm going to take the mass divided by the volume. And in this case, yes, density is mass over volume. I have the mass. And now we got to figure out the volume. So let me read this last one. The image shows the water level after the substance was placed in 60.0 milliliters of water. So let me go look over here. Well, 60.0 milliliters, that's here. So that's the original volume. And what happened? It raised up. Oh, that makes sense because the image shows the water level after something was placed in there. So it was raised up to this amount. When you're reading a graduated cylinder, this curve is called the meniscus, and you have to read to the bottom of the meniscus. That is the standard that we have set because it's easier than reading the top or the middle. And why did we go up to the top? That's when we're going with that surface tension and capillary action. So it's trying to crawl up the sides. So the bottom of the meniscus is where we're going to measure to. So we're going to measure to right about here as our new water level. And the difference or the subtraction of those two will be our displacement. So now I got to remember, what rules do I have? Okay, a digital scale, I read exactly how it is. But an analog thing like a graduated cylinder where I have to read the gradations, how we separate the lines here. When I have to read them, I always give one more decimal place than is given with the gradations. So that's not 60 and 70 as reading it, because that guy is only in the tens. This is every 10. But my gradations here, how much are they? Well, this guy here is halfway between. He's 65. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of those gradations is 1. So one more that I'm going to be going 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. One more decimal place means we're going to be measuring to one decimal place because that is one more than the ones. So when I look here, it is halfway between the 63 and the 64. So 63.5 would be my answer. You're not even going to try to estimate more. If it looks 3/4 of the way, you're not going to say 63.75. You're going to say 63.8 because we can only do one more decimal place than the gradations show. And that's why a beaker is not so accurate, because a beaker only has things about here. So we can estimate here somewhere between If the water level is down here, we could maybe say 55. Okay, that's even going to be a maybe even too much of an estimate with those hundreds place up there. So anyway, this guy halfway in between the 63 and the 64, so 63.5 milliliters is my density. My formula, density equals mass over volume. So after we did all that, we still got to come back and solve the problem. So always make sure you're answering the question they ask, because they can give you two-parters in these SOLs. My mass is 10.0 grams. My volume is 63.5 milliliters. So 10 divided by 63.5 gives me 0.0157 for my grams per milliliter. Now, if you have not done sig figs yet, this is where you would stop. However, we probably have done sig figs and definitely before the SOL. So let's just review that. 1, 2, 3 decimal places, because when I see the decimal and the trailing zeros are the zeros on the right are significant. 1, 2, 3, all non-zeros. Both of these have 3 sig figs, so my answer has to be 3 sig figs. Okay, leading zeros are never significant. 1, 2, 3. I have 3 sig figs in my answer. That does not make my answer 0.157, 1.57, 157. My answer is still 0.0157 grams per milliliter. It just only has 3 significant figures in it. Okay, and a triple beam balance, so you might have had to do some estimating as well if you were on a triple beam balance as opposed to a digital scale in middle school. All right, here we got our nice little metric ladder. Let's see how we do on that. You got to always make sure that the roots match. So I'm going from liters to liters, so I'm converting units of volume. I have deciliters here, 200 deciliters. And I'm changing to decaliters. So I am going up the ladder. I'm going from deci to deca. Notice they look really, really similar, but they are not. They're 2 steps apart. 1, 2 steps to the left. So even though I don't see the decimal, I know he's estimated right there. 1, 2 hops to the left. So 200 deciliters is 2 decaliters. Now, how do I know sig figs again? Significant because it's between 1 and 9. Trailing zeros, I don't see the decimal. Even though I knew where it was, I don't see it. So my answer should only have 2 sig figs in it. So there is my correct answer for that. And another one. This one. We are going, they're both grams. You got to have the roots matching to work. And then we're going from kilo, because that's the K, to milli all the way down here. So milli is another one that can get confusing. Micro has the little mu or almost a script M. Mega has the capital M, but I need the milli. 1, 2, 3, 4, 5, 6 steps, this time to the right. So I'm going to add 6 hops to the right. 1, 2, 3, 4, 5, 6. This is my new decimal location. And then fill in my zeros. 2, 5, 0, 0, 0, 0, 0, 0. Okay, and then go back and add in my commas. 2.5 million. Now, can I leave my decimal place there? If I leave my decimal place there, I have significant, because non-zeros are always significant, and trailing zeros, I see the decimal, 1, 2, 3, 4, 5. That makes this whole thing 7 sig figs. Did I start with something that specific? No, I only have 2 sig figs there. So if I leave this decimal place there, it's saying it's much more accurate than it is, because I don't actually know if it's 2.51 kilograms, 2.48 kilograms. Somebody rounded to 2.5. So I cannot leave that decimal there. So my answer is just going to have 2 decimal places. Remember, if you see a comma, that does not count as indication that you're trailing zeros or Your zeros to the right are significant. Trailing has an R for right, the whole set to the right. Okay, so there are those two little conversions there to help with conversions. You can't do 200 deciliters is how many milligrams. You would need another conversion between liters and grams to do that. All right, looking here on the conversion tager, 1 kilometer equals 1,000 watts. 1 meter equals 100 watt. So you have that little metric ladder. They're not going to give you that on the SOL. So that's why that numeric was on that page before to help you out. Let's go back to that since I didn't point it out on that page. Okay. The great mighty King Henry died by drinking chocolate milk, messaged Nancy properly. Okay, so this does not have the V for terrors or the G for gigas. It starts with mighty for mega, kilo for king, and then so on. Okay, so that is the mnemonic to memorize for you going that way. And so now when we go to this next page, we have kilo. King Henry died by drinking chocolate milk, messaged Nancy promptly. 1 kilometer is equal to 1,000 what? Kilo is on the big side. So when we go down, we're adding how many zeros? 1, 2, 3. So we're going down because we changed the 1 kilometer and we wanted to add 3 zeros. So we're going down. 3 zeros gets us to the B. Kilo, hecto, deca, base. 1 kilometer equals 1,000 meters. So now I'm going to look at my answers here. 1 kilometer equals 1,000 millimeters. Nope. 1 kilometer equals 1,000 centimeters. Nope. 1 kilometer equals 1,000 meters. 1 kilometer equals 1,000 meters. So it's either B or D. So now I do need to know what the next ones are. 1 meter equals 100 what? 1 meter, that's our base units. We're making it bigger by how many hops? 1, 2 hops. 1, 2. That's a C for centi. So there is my correct answer for that one. All right, so now scientific notation always has a non-zero number in the ones place times 10 to the something, and there is no number in the tens place. So 2 of these are incorrect. One of them's harder to spot than the other. So hit pause and look at them, see if you can figure out one or both of them. You can do all the problems this way. Hit pause, try them, and then hit play and check your work. Okay. So that guy over there is not in the correct place because my Y value, what was in the exponents, was a 3.1. That is improper. You have to have an actual number in there. So that does not count. And the other one that does not count is this guy because he had 15. He had a 1 in the tens place and a 5 in the ones place. These ones that are remaining, all of these are scientific notation. 4 times 10 to the 13, 10 to the third, 5.0 times 10 to the negative 3, 9 e to the negative 4. This is how your calculator likes it. Okay, and then if you've been using some of the LMSs like Canvas, also like it, like that. So now we want to write it in expanded notation. When I see a positive exponent, it means I'm going to have a large number. If I see a negative exponent, it means I'm going to have a small number. So that is going to help us with the hops, same type of hops that we're doing before. So if I'm in scientific notation and it's a large number, it means I'm going to go to the right with my hops. How many hops? 3. So at 4, going 3 hops to the right. Where's the decimal place? Right here, even though I can't see it. 1, 2, 3. Fill in the zeros. 4,000. Okay, there is a 1 sig fig here because we don't count sig figs after the X. It's just a placeholder. You still need to say 4 times 10 to the 3. 4 times 10 to the 3 is not equal to 4. But in terms of sig figs, I have, again, two choices. I could write 4,000 showing the decimal or 4,000 not. My sig figs have to match. So my answer is going to be 4,000 without the decimal place here. The second one, 5.0 times 10 to the negative 3. I have a small number because I have a negative number in the exponent. So my hops have to go to the left from getting rid of scientific notation and going to expand it. 5.0, and I'm going to go how many hops? 3. 1, 2, 3. Here's my new decimal place, 0.0050. Now, should my answer be 0.0050 or 0.005? Let's go back. 5 is significant because I see the non-zero. This 0 is a trailing. It's on the right. If I see the decimal on trailing, it's significant. Don't count anything after the X. So I have 2 sig figs. So when I look down here, what is the other rule? Leading. Those are the zeros on the left side. So these zeros are never significant. So they are going to get some X's. It's still important. My answer still is going to have 2 zeros between the decimal and the 5, but they are not significant. 1, 2 sig figs in this top one, 1 sig fig only in the bottom. So my answer is going to be 0.0050. 2 sig figs. Make sure your sig figs match. I over here, negative, so he's a small number. By how many hops? 4. 1, 2, 3, 4. Here's my decimal place, 0.0009. 1 sig fig here because we don't count anything after the X. This is the same thing as 9 times 10 to the negative 4. That's just like how our calculator likes showing it. All right, so when I rewrite 0.009, these are not significant. They're leading, they're to the left, so there's only 1 sig fig there. My answer still includes those zeros because they're important placeholders. Okay. And then there is also another video on doing this on Desmos. The SOL should give you a Desmos calculator this year, in which case you might want to know how Desmos works to be able to use it that way, especially with the exponents and dividing. Okay. All right, so now we have expanded notation. We got to find scientific. We need a non-zero number in the ones place, but nothing in the tens place. So we got to figure out where the decimal place goes. So on this guy, my decimal is here, and how many hops to get the 5 just to the left of the decimal place? 1, 2, 3. So that means right now, before I go any further, I know it's 10 with the 3 hops. Positive 3 or negative 3. It is a small number, 0.0050, so it is a negative 3. 5 times 10 to the negative 3. Now, sig fig wise, let's go back and count. Leading zeros, never significant. 1, 2, 3, 4, 5, always significant. Trailing zero, significant if I see the decimal. So my answer has to have 2 numbers in it. If I put a 0 here, leading, still not significant, so that's not going to help. If I put a number here, hey, now I might have it. Nope. 50 times 10 to the negative 3 is not the same as 5 times 10 to the negative 3. So we've added a whole new thing. We know the decimal place is here, and add a 0. 5.0 times 10 to the negative 3. Now we have the 2 sig figs. Hey, 3,040,000. Where do I know the decimal place is estimated? There. Where do I need to get it? Over here, so that there's only 1 number in the ones place. 1, 2, 3, 4, 5, 6 hops, 10 to the 6. Was it a big or a small number? It's a big number, so it's positive. Something times 10 to the 6, 3.04. And then let's check our sig figs. Non-zero significant, numbers that are trapped. All of these guys, doesn't matter if there's a comma or not, all these guys are trailing zeros, and I don't see a decimal, so he is not significant. So my answer can only have 3 sig figs, 3.04 times 10 to the 6. This guy here, the decimal's really close, but where does he need to go? One more to that left side, one hop to the left. Okay, on this number, even though the number is kind of small, 23, we made it even smaller, so it still counts as a big number. 10 to the 1, positive 1, one hop, 2.345. 1, 2, 3, 4 sig figs, 1, 2, 3, 4 sig figs. 2.345 times 10 to the 1. Here's your trick question of the day over here. This guy doesn't have one. He's already has a number in the ones. 10 to the 0. Why? Because 10 to the 0 is equal to 1. So I'm just saying 5 times 1 here. 1 sig fig, 1 sig fig. All right, the speed of light is about 300 million meters per second. What is the correct expression for the speed of light in scientific notation? All right, this is where I estimate the decimal to be. 1, 2, 3, 4, 5, 6, 7, 8. 8 hops, positive or negative. This guy is big, positive. 3 times 10 to the 8. Okay, so I have 30 times 10 to the 7th. That's not scientific notation. So it could be correct, but it's not scientific notation. Why? It has something in the 10 spot. 30 times 10 to the 8 is not the same as 3 times 10 to the 8. So the only ones with only a number in the ones and no number in the zeros is C and D. And I see it's 8 hops. So this is my correct answer. Okay, what is 10 to the 4.5 and expanded in scientific notation? You cannot leave it like this. So you got to plug it into your calculator. 10 and then the AB button and then 4.5 is how you would do it in Desmos. There's lots of different ways. So make sure you know how to use your particular calculator. So you can try it now and see if you get what I get. 31,622.7766, and it does continue on like that, but I am only going to keep, let's just round to the nearest ones here. So I'm rounding to the nearest ones or whole number or 0 decimal places. It could call it any of these things if it tells you they're rounding. It might say use sig figs or round to the nearest this. So the ones place, the whole number, and 0 places is all rounding to this. I look over, it says 7. So I'm going to round up ones. 31,623 is my answer in expanded. What about scientific? 31623. I know my decimals here. 1, 2, 3, 4. 4 hops. Was it a big number? Yep, so it's a positive. 3.1623 times 10 to the 4th. What's nice about scientific notation is it makes it easier to correct your answer. This is still rounded to the nearest whole number as it is. But they could also say round to 2 sig figs. Okay, so this is a totally separate problem. We've already answered the one that it gave us. But what if instead of saying round to the whole number, they rounded to 2 sig figs? Underline the first 2. Look next, 3.2 times 10 to the 4. So lots of different practice you can use there with scientific notation. How many different elements are involved in the chemical reaction shown? How do I know it's an element? It has a capital letter at the start. Every guy has a capital letter at the start. Ca, since this A is lowercase, this whole thing is one element and it's calcium. H, capital letter, hydrogen. O, capital letter, oxygen. Okay. Calcium again, oxygen again, hydrogen again. So there's only 3 different elements involved in the chemical reaction. That's because of conservation of mass. I can't magically create or destroy the calciums, the hydrogens, or the oxygens. So on the left side of the chemical reaction, they exist, then they have to exist on the right. They also have to exist in the right amounts. 1 calcium on the left, 1 on the right. 4 hydrogens on the left, 4 hydrogens on the right. There's 2 spots. I can't count. 2 hydrogens plus 2 hydrogens is 4. 2 oxygens on the left, 2 oxygens on the right when we distribute from those parentheses. Right, if P is 300, V equals 5, N is 0.25, R is 8.31, what is the T? And they give us this equation. Even if they don't show it, when you see variables right next to each other, they're multiplied. So I'm just going to take, and instead of saying P, I'm going to write 300. Instead of saying V, I'm going to write 5. Instead of saying N, I'm going to write 0.25. Instead of saying R, I'm going to write 8.31, and T is what I'm solving for. So anytime you have a variable substituted in everything except one variable, one equation, one unknown, you know you're ready to put your math brain on to solve. So let's just rewrite that same thing. 300 times 5 equals 0.25 times 8.31 times T. This is a single equation and one unknown. First job, always combine like terms. 300 times 5 on the left is 1,500. 0.25 times 8.31 on the right is 2.0775. It's connected to the T with multiplication, so we got to divide. What we do to one side, we got to do to the other. And now it's divided out on the right. Only temperature is left, and on the left, 1,500 divided by 2.0775 gives me 722.021661. So this would be the answer if you didn't know sig figs. If you know sig figs, you'd have to go one step further. 1 sig fig in 300, because those trailing zeros do not have a decimal place, so they're not significant. They're still important. I still have to use 300 in my calculation, but my answer is only going to have 1 sig fig. Now I can go check the other ones, but I can't ever get below 1 sig fig, so I know I can just stop. I underline the first sig fig. That guy is at the 100 spot. So I'm going to round to the nearest 100. So I'm either going to round down to 700 or round up to 800. I look at the 2 and I'm going to round down. So 700 is my answer for T. If 2 legs of a right triangle, okay, right triangle. So they have that 90 degrees, are 30.5 and 10.0. What is the hypotenuse? So remember, the hypotenuse is labeled as C, and I can use Pythagorean theorem. A squared plus B squared equals C squared. Okay, does it matter which one's A or B? Nope, as long as they're legs, they can be A or B. 30.5 squared plus 10.0 squared equals C squared. I'm going to combine like terms. So first, I'm going to get rid of those exponents. I don't have parentheses, but I do have exponents. 30.5 squared is 930.25. 10.0 squared is 100. So now I can add 930.25 plus 100. I'm combining those like terms. Gives me 1030.25, and that's C squared. I don't want to answer in C squared, so I got to get C just as C. So the opposite of squared is square root. What I do to one side, I got to do to the other. So C is equal to 32.0975, and then some other things. But I know I can stop early because of sig figs. 1, 2, 3 sig figs. 1, I see the decimal, so the trailing zeros are important. 3, my answer needs to be 3. 1, 2, can I underline this 0 or not? It's a trapped 0, so it's always significant. so it does get an underline. I'm going to round this guy to the tenths place or the 1 decimal place, because that is where my last underline ended up. So I can either round down to 32.0, round up to 32.1. I look next, it's a 9, so I'm going to round up to 32.1. So hopefully you're getting some good practice with rounding here. You can also round in Desmos, and that is, again, another video you can watch. A over B equals C over D, and A is 5, B is 3, C is 4.25, D is unknown. So now I'm just going to rewrite it. 5 over 3 equals 4.25 over D. You can do lots of different ways on this, but if you don't remember that D is in the denominator, that's when you can run into trouble. So cross multiply and divide works. Cross gets the multiply, and the divide is the other thing. So that would be, cross the two things that have numbers, and then divide the other. I usually have it, normally it's a problem in chemistry, it's the other way around, so I just naturally write it. 3 times 4.25 over 5 would give us our answer that way. So that's one way to do it. 3 times 4.25 divided by 5 is 2.55. Your other option is 5 over 3 equals 4.25 over D. You can cross and leave them together on that side. 5 times D gives me 5D on the left. 3 times 4.25 gives me 12.75 on the right. The 5 is connected to D by multiplication, so I have to divide, and I get 2.55. So either of those ways works. Where people run into trouble is they don't notice the D is in the denominator, and they try to just combine like terms, and then they divide the 4.25. You can't divide the 4.25, he's on the numerator. Okay, and the D is on the denominator. So it will end up giving you a 1 over D answer. All right, substitute, solve sig figs, 1 sig fig on each of those. So 2.55 would either round down to 2 or up to 3. My answer is 3. Always substitute, then solve, then do your sig figs. All right, so if you took the benchmark and you get 15 incorrect out of a total of 43 questions, and there's 1 point per correction, what is your grade? So if there's a total of 43, part over whole, I would have 43 points. I got 15 wrong, so 43 points minus 15 is the part that I have. 43 minus 15 is 28 for the numerator. My part, I got 28 points because I got 28 correct. Divided by 43 gives me 0.65. And now times it times 100. And that gives me a 65%. And that's all for today.